Okay, good day. This is Math 130 Introduction to Statistics. I am Professor McCulley, and this is lesson number 11, the addition rule. Let's get to it. Today we're going to determine whether two events are mutually exclusive or disjoint, and then we are going to use the addition rule to find the probability of two events. So first, two events, A and B, are mutually exclusive, or also known as disjoint, when A and B cannot occur at the same time. Note, A and B must occur in the same sample space, so Venn diagram. A and B are mutually exclusive when they have no overlap. They are not mutually exclusive when there is an overlap between A and B. And so what does that mean in a real world sense? So determine if the following events are mutually exclusive. So event A and B happening at the same time. Um, what is the probability that I draw an ace or a king from a standard deck? Well, those two events, since there is no overlap between aces and kings, these are mutually exclusive or disjoint. Draw an ace from a standard deck or draw a heart from a standard deck. Well, these are not mutually exclusive because there is a heart that is an ace. And so if I'm looking at here, think of this one. Here is draw an ace. Here is draw king. There's no overlap between those two. But if I say draw an ace and a heart, in this one is the ace of hearts. And so that's where we get that overlap. Here, randomly select a driver with a blue vehicle, or randomly select a driver that has a truck. These are also not mutually mutually exclusive because there could be a B a blue truck. So there we go. All right. Addition rule for probability of A or B. The probability of events A or B will occur. Probability of A or B is given by probability, and this symbol here is the union symbol. I don't know if we've talked about it, but if you need me to go over it, you can ask in class. Probability of A union B is the probability A plus the probability of B minus the probability of A intersect B. So this is subtracting the intersection of that. If the events are mutually exclusive, then the rule can be simplified to just the probability of A union B equaling to the probability of A plus the probability of B, and we can simplify it by just scratching this part out. I don't know why that's in there. We need to get rid of it. Okay, so what does that mean in an example? If you draw a card from a standard deck, what is the probability that the card is an ace or a king? Well, we've already determined that these are mutually exclusive events. So the probability of an ace or king, that means that there are 4 out of 52 aces plus 4 out of 52 kings, giving me 8 out of 52. And let's see here, 8 divided by 52 is 0.154. So you've got a 15.4% chance. You draw a heart from a card from a standard deck. What's the probability that has a heart, ace, or a heart? And again, there are 4 aces in the deck, and there are 13 hearts in the deck. But if we do it like this, we've counted that ace that is a heart twice, once in here and once in there. So we have to subtract away one of those countings, which is the probably that it's an ace and a heart, and there's only one ace and heart. And so we would get 16 out of 32, or 52, excuse me. 16 out of 52, which would be twice that, but we'll just do it. 16 divided by 52 is 0.308, 308.308, which is twice that one. All right. Example, use the addition rule to find probabilities. Professor McCulley records the class his students took immediately before taking statistics and then records if the student passed or failed statistics. If a student was selected at random, what is the probability that they were an algebra or college algebra or algebra 2 or college algebra 2 student? So the probability algebra 2 or college algebra. All right, so there are algebra 2 and college algebra. There are 18 out of 85 algebra 2 students. There are 19 out of 85 college algebra students. There's no overlap. These are mutually exclusive. And so let's see here. 18 plus 19 is 37. So 37 out of 85. And 37 divided by 85. Oops, I said 35. Let's get it right there. 37 divided by 85 is 0.435. 0.435. Okay. What is the probability that they were an algebra 2, a college algebra student, or a student that passed the course? Oh, okay. That they were a college algebra 2 student or a student that passed the course. Well, there's some overlap there because we have 58 total students that passed the course, but 10 of those were already college algebra. So these are not mutually exclusive events. So the probability of college algebra or passed would be, again, college algebra, there were 19, so 19 out of, not 18, I said 19, wrote 18. So it would be 19 out of 85, and then passed, there were 58 students out of 85 that passed. But again, we've counted these 10 college algebra 2 students twice, once in the 19 and once in the passed column. So we have to subtract away the college algebra students that passed, so minus 10 out of 85. And so let's do that. 19 plus 58 minus 10, and let's make sure I got that right. 58 minus 10, okay. Hit enter, that'll give me 67. So 67 out of 85, which is 67 divided by 85 is 0.778. 0.778. So those are my two possibilities. All right. There are some examples on the addition rule and mutually exclusive or disjoint events. Finally, The Marvel fun fact of the day: on his faked gravestone, Nick Fury has the inscription, "The path of the righteous man," an obvious reference to a quote spoken by Samuel L. Jackson from his character Jules that he played in Pulp Fiction. That's all I got for today, folks. Have a great day.